So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the participant branches for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Today, we are going to start a new chapter, pressure. Of course, today is the session number 1. In last class, we completed the chapter number 4, work, power and energy. And today we are entering into the 5th chapter, pressure. So the word pressure is applicable in our day-to-day life in various stages or various ways, differences. We are feeling pressure to do work. We are feeling pressure to study during examinations, feeling pressure when you are doing any other activities. So many where you use the pressure in different terms like stress, strain, pressure. All these are the common used term in our day-to-day applications. So in physics point, even blood pressure, you can see blood pressure here. So the pressure plays vital role in our regular applications. So we'll see exactly what is the pressure, okay, as per our material, as per our. So we have the page, 5th chapter here, page number 110. We check pressure. So in this chapter, we learn about what is thrust and pressure, what are the applications of pressure in our day-to-day life, what are the pressure in fluids, means pressure not only applicable in solids, it also applicable in liquids and gases. So liquids and gases together called fluids. And then what is the law of liquid pressure? It's also an atmospheric pressure and Pascal's law and its application. So these are all the concepts what we are going to learn in coming 3 to 4 days in chapter pressure, right? So when you start with first topic, that is, you can say clearly. So we observe that a balloon filled with hydrogen gas gets up, but a balloon filled with the air falls down. A small iron knight sinks in water, but huge ship made to flow of iron float. To seek answers to these questions, we need to understand how liquids and gases at rest reacts external forces. This involves the study of branch of physics called hydrostatics. Study about the pressure. You know, some take small lead and drop it in the water. It will sink. But why not a big boat, ship? It is floating. How come that heavy aeroplane flying in air? Air is very light, but still aeroplane flying. How? All these doubts will be cleared by end of this chapter. Right? So start the chapter with the word thrust. The total force acting on normal on a body is called thrust. Suppose this is a body, some body it is there, placed. Normal means perpendicular. Suppose force is acting. So force acting perpendicular to the body is called thrust. Right? For example, a weight example, the book placed on the table. When you place the book here, right? So the weight of the book always acts in downward direction, perpendicular to the surface or table. That is called a book is exerting thrust on table. So what is the units of thrust here? Thrust is nothing but force only. Since thrust is a force, its units are same as force. That is Newton or dyne. Newton in MKS or SI system, dyne in CGS system. Whereas another units also there, gravitation in terms of gravity. When a body is affected by gravitational force, they are measured in kg weight or gram weight. Right? So thrust is a vector quantity. It has both magnitude and direction. It acts in a particular, because as it acts along the direction, not normal, direction is there. So when direction is there, it is called as a thrust. Thrust is nothing but a force acting perpendicular to the body. That's all. Means nothing but force only, but in a specific direction. Book placed on table. So the book will exert thrust on table in a perpendicular direction. As it is mentioned in the direction, it is a vector quantity. Next comes the very important chapter term, pressure. Thrust acting on unit area of the surface is called pressure. Thrust by area. Pressure is nothing but thrust by area or force by area. Pressure is equal to force by area. Force or thrust by area. Right? So thrust acting on unit area is called pressure. So units of pressure, force Newton, Newton, area is meter square, Newton per meter square, or dyne per centimeter square, or Pascal, named after the scientist. Standard unit of pressure is Pascal. Right? So thrust is nothing but a force acting perpendicular to the body. And the force acting per unit area is called pressure. When a force is acted in a particular area, we'll get the pressure. Right? That is measured either in Newton per meter square or in dyne per centimeter square or simply Pascal. Okay. So Newton per meter square is given clearly here. Newton per meter square is called Pascal in honor of French scientist Blaise Pascal. So 1 Pascal is equal to 10 dynes per centimeter square. Pressure is a scalar quantity, no direction. Other units of pressure are bar or atmosphere. Bar also the one of the unit of pressure. Right. So pressure is Pascal, bar, torr. Right. So 1 bar is equal to 10 power 6 Newton per meter square or 10 power 8 pascals. Okay. The relationship between these also, one of the unit of Pascal, bar, torr, even ATM you can call it, 8 atmospheric pressure. Atmospheric pressure also one of the unit for the pressure. Right? So these are the pressure is thrust per unit area or force per unit area. It is measured in Newton per meter square or dyne per centimeter square or Pascal or bar, or the relationship also given, what 1 bar is equal to how many Pascal, 1 Pascal is equal to how many bars. Right? Conversion also there. So applications of pressure. Where this pressure is applicable, where we can see this pressure. So animals like camels walk easily in desert as compared to the horses or donkey, because they have broad feet. Broad feet exert less pressure on the sand. Wonderful example this is. So when you say camel in the desert, you observe carefully camels' foot, right? Their feet are very large. So because of the large area of cross section, you know what is the pressure? Pressure is equal to force by area. When area is more, pressure is less. Greater the area. See, when you compare to horse or donkey or human being, the camel legs are very big area. So because of more area, less pressure falls on the floor. So they can walk easily. But we cannot walk on beach or sand areas, deserts, because our foot rest is very less area. Greater the area, lesser the pressure. Lesser the area, greater the pressure. Clear? That is one example. Then heavy truck is fitted with the 6 or 8 wheels. This increases the area of contact on the which the weight acts on, hence reduces the pressure. When you see a two-wheeler, three-wheeler, four-wheeler, five-wheeler, when you see very big truck which contain the containers, there are so many wheels. Why they are using so many wheels? Greater the number of wheels, greater the area of contact with the road. As the area of contact increases, pressure on the vehicle decreases so that it moves along the road smoothly. Very, very important application of the pressure. One is, you can see camel walking in a desert, and second one is a heavy truck with more number of wheels. Also example where pressure can be exerted. Third example, you can see the skiers uses flat and long skies on slides on the snow. You might have seen so many movies also. They'll use the skiers, those who are moves around the ice. They use skaters. Skaters are made up of very long and wide, right? So flat and long slides to slide on the snow, because larger the area of the cross section, the lesser the pressure on the snow. As you feel the less pressure on the snow, they can move easily. Hence, skiers can easily slide over snow without sinking into the feet into the ground. So they'll have the slides, long slide. With the slides, they move along the ice without sinking. Then the cutting edge of the knives, blades and axes are sharpened. Why you keep sharpening the knife or axe every time? Because area is less, pressure is more there. Therefore, sharpened, as the cutting edge is sharpened, the area of contact decreases. Because when sharp happen, what happened? Area decreases. So when area decreases, what happened? Pressure increases. When pressure increases, we can cut the vegetables or wood easily. That is the reason we need to sharpen our knives or axes again and again. Hence, the person pressure exerted by the increases, thus they can easily penetrate through given surface. As long as you are keeping the axe sharp, you can cut the wood easily. As long as you are keeping the knife sharp, you can cut the vegetables easily. Why? Because by sharpening, the area of contact decreases, automatically it increases the pressure. You can do our work easily. Next, the foundation of high-rise buildings are kept wide so that they exert less pressure on the ground and do not sink into due to extremely high pressure. The foundation, how much light, very high foundation, that much strongly the building will stay. So we cannot build the building with a small area, high level. Pressure increases because of gravitational force, weight of all the things are coming down only. So it should be wide. That is, pressure is equal to thrust by area. Okay. So these are the applications. Formula, same formula only. So pressure is directly proportional to thrust, inversely proportional to area. Area increases, pressure decreases. That is, example is camel and sky skaters. If area decreases, pressure increases. Example is knife and axe. So anyway, the pressure and area are main reason for the increase or decreasing of the pressure, where we can see the 5 important applications in our day-to-day life, what we commonly observe. Either maybe camel, the feet of the camel is very wide. That is the reason it walks easily over a desert. It is not possible with the horse or dog or human being. Whereas the skiers slides easily because of the slides. What they have is having the wide area. And of course, the knife and axe are always keep sharpening, because as they are sharpening, area of contact decreases, because of that pressure increases to do our work easily. Right. So before going for the next part of the pressure, let me show you one video on the what is exactly the pressure. Sorry, just a minute. Missing somewhere.
This screencast is going to discuss a little bit about pressure, the types of pressure, how to convert from one to another, how to use them in calculations and so forth. Just be a quick overview. So the first kind of pressure we're going to talk about, let's use a big tall glass of water and talk about fluid pressure. If we put a hole in that glass, then the pressure that fluid exerts would be equal to the pressure you would have to exert on a cork to fill that hole, right? So the forces counterbalance each other. And we know that pressure is a force over an area. There's many different units.
About liquid pressure.
మీ కలీగ్స్ కూడా మీ కుటుంబంలో భాగమే. వారి సేఫ్టీ విషయంలో రాజీ పడటమా? నో ఛాన్స్. అందుకే పాలీక్యాప్ గ్రీన్ వైర్స్. వీటి సుపీరియర్ ఇన్సులేషన్ ఎమర్జెన్సీలో వదులుతాయి తక్కువ పొగని. పాలీక్యాప్ గ్రీన్ వైర్స్, ఇండియా యొక్క సేఫ్ హ్యాపీ కనెక్షన్.
When you hammer an iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, then applies the force on the wall and tries to pierce it. Now let me ask you an interesting question. What will happen if you hammer the pointed side and try to pierce the flat side of the nail? You will find it difficult to push the flat face of the nail through the wall even if you apply more force than you did in the first case. What is the reason for this? The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface.
Area is more.
But the question is why?
Here area
First,
is less,
notice
pressure
that
is
the
more.
area of the tip of the nail is very less as compared to the area of its flat surface. This tells us that the area of the surface on which the force is applied matters. We will understand this in detail, but first let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it's acting. It's easy. Force acting per unit area. We already know that the SI unit of force is Newton, denoted by N, and that of the area is meter squared. So the SI unit of pressure is Newton per meter squared. It is also called Pascal, which is denoted by PA. Why is it called Pascal? It is given this name to honor the achievements of a French scientist named Blaise Pascal for his contributions in hydrostatics and hydrodynamics. Observe the equation carefully. Area is in the denominator of the fraction. What is this area? Well, this area is nothing but the area on which force is applied. Say I keep the force constant and I keep increasing this area. What will happen to the pressure?
Decreases.
Will the pressure increase or decrease? Use pure mathematical logic to answer this. If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Surely it will decrease. So the pressure will decrease if I increase the area while keeping the force constant. With this newfound knowledge, let's go back to the example we saw earlier, the nail and the wall. Notice that we are also applying the force perpendicular to the surface of the wall. The angle between the nail and the wall is 90 degrees and not anything else. If you notice, the tip of the nail has a very small area compared to the flat surface of the nail, and hence the area of contact with the wall reduces to great extent in the first case. Hence, the pressure applied by the tip on the wall is greater than the pressure applied by the flat surface. That is why it is easy for the tip of the nail to penetrate through the wall. You can even use drill machines to drill the hole into the wall. You see that it has the pointed tip for the same reason. You can easily cut the vegetables using the cutting edge of the knife. But if you use the blunt edge of the knife, it will be difficult to penetrate it in. What is the reason in this case?
That's not what we discussed.
Well, in the first sight, the two edges might look the same to us. But if you look at them carefully, the cutting edge has small triangle-like shapes with sharp outer points. The other edge has nothing of these. So if you cut a vegetable with a cutting edge, the area of contact between the vegetable and the knife is greatly reduced. Hence, more pressure is applied on the vegetables using cutting edge of the knife.
Sharp
Area used to cut the trees also have sharp cutting edges instead of placid ones. It increases the pressure on the tree due to the less area of contact. The examples that we've seen so far are applications of high pressure.
So these all are the
It's about
applications. What we have seen just now, these are all application of the pressure. Okay.
how high pressure is useful to us in some cases. But it is not always the case. There are situations where we require low pressure. Let us see some applications or advantages of low pressure. We use snowshoes to walk on snow. The reason for that is simple.
Snowshoe.
Due to the larger area in contact with the snow, snowshoes reduces the pressure on the snow. We are able to walk on it without our feet sinking deep inside. In case of normal shoes, due to comparatively smaller area of contact, the pressure on snow is more and it sinks our feet deep inside. Note that the force applied on the snow in both the cases is the same. This force is nothing but our weight on the snow. Have you ever wondered why the wheels of an army tank run on the steel tracks rather on the ground? Notice that the wheels are on steel tracks and are not touching the ground. The army tank is huge in size. If the wheels run on ground, due to less contact area with the ground, the pressure on the ground will be massive. However, the tracks have much larger area of contact with the ground and hence the pressure on the ground is reduced to a great extent. In all the examples that we have seen in this video, it is the solid which is applying pressure on another solid. Do liquids also apply pressure?
That we'll see. As we are not done with liquids, we'll discuss later. Now we are ready with the solids only, right? Solids only exert the pressure what we have seen till now. So there are so many applications are given what we have seen here and some extra also even army tanks, how they move, not on road, on track. All these are where area is more, pressure is less. Some places we need less pressure, some places we need more pressure. If you want more pressure, area of contact should be less, like sharpening of knife or axe. Where we provide less pressure, like over ice slides, so we'll have the more area. More area, less pressure, less area, more pressure when the force is constant. That is, pressure is directly proportional to force and inversely proportional to area of contact. That is a simple funda what we understood till now with various day-to-day examples. Okay. Clear? Now, just to start doing about what is the pressure in fluid. So what is fluid? Both liquids and gases together called fluids. Why? Because they flow. Fluid is the one which flow. Suppose there is a drop of water on the floor, what happened? It will flow. Similarly, gas always will flow. So the both together liquid plus gases which flow are called fluids. So just now what we have seen is only the solids, pressure exert on solids. Now this is the pressure exert on liquids and gases, exerted by liquids and gases. Suppose we are blowing air into the balloon will bulge. Why? Because of the pressure exerted by the gas. Air what we are sending applies on the walls of the balloon and it makes the balloon to bulge. Suppose you take one rubber ball and drop it into the water. It will come back. It bounces back because the pressure exerted by liquid. Liquid exert pressure on the ball, due to which it will come up. So like that, there are various types of pressures are there applied by the fluids. Either it may be downward pressure, upward pressure, lateral pressure, as well as different types of pressures exerted. Okay, upward pressure is also called upward thrust, upward pressure. Downward pressure, exert pressure downward direction also. When you make a hole at one corner, so because of pressure acting downward, the water will flow from that holes. Right. So these are the different types of pressures which we'll discuss in the next class. The pressure exerted by the liquids and gases, which are together called as fluids. Okay. So far we discussed only about the what is pressure what is thrust first, what is pressure, and what are the applications, various applications of pressure in our day-to-day life, how the area of contact decreases and which affects the pressure increases, by which we can insert the nail into the wall. The sharp edge of the nail is placed towards the wall and hit on the large area. When you are hitting like that, automatically the nail is inserted because of the application of pressure. Camel walks freely on desert land than the donkey or horse or human, because the feet of the camel is very wide. As area of contact of the feet of the camel is more, the pressure exerted on the ground is more. Pressure exerted is more because of that it moves smoothly over the desert area, right? Similarly, knife, why the knife or axe is sharpened? Because the area of contact with the vegetables or a wood or tree when you are cutting, as the area of contact is less, pressure is more. So that you can cut the vegetables easily with the sharp edge than blunt edge. Clear? Right? And you have seen the war tank, how it is, why it's not moving over the ordinary ground, because of the more area and heavy weight. It cannot travel over the roads, it is traveled through the track. A specific track will be there to minimize the pressure. So pressure not only exerted by the solids, even you can see the pressure exerted in the liquids as well as gases, which are together called as fluids. This liquid pressure as well as the gaseous pressure leads for so many laws like Pascal's law, Bernoulli's principle, right? All these laws based for which we can see so many examples like how the ship is floating over water when small nail will sink. How aeroplane is flying in light air. These all are because of the pressure. When the cricket bowler bowls, why the spin? What is the reason for spinning of ball? What kind of pressure exerted on the ball to spin the ball? All this explain these particular fluids. When you discuss know about the fluid pressure, we'll come across all those things, right? You can see here. What is the upward pressure? What is the downward pressure? What is the lateral pressure? Okay. So mathematical expression will come. So some laws are there for the liquid pressure. Then atmospheric pressure, very important. In atmosphere also there is a pressure is there. So that will impact our blood flow. Right. So pressure exerted by atmosphere, which is 76 centimeters we can measure. Right. So what is the standard atmospheric pressure? Of course, mathematical formula for that. How the pressure transmits in liquids from one place to another place. Then we'll come across the Pascal's law, very important, where we can find the so many applications of this Pascal's law, like hydraulic machine. When your oil seeds are crushed, they'll use the Pascal's law application only. When you are taking your four-wheeler for the servicing, what they'll do, they'll take the four-wheeler to the pit. That pit will raise for cleaning the car. What is that pit? Works on the principle of hydraulic only, water pressure. Because of hydraulic pressure, that happens. So that is simple. One day we'll discuss in the next class. What are the fluid pressure followed by the Pascal's law. With that, we can finish up this chapter in the next week, next 1 or 2 classes. Right? Simple. What are the liquids only? What are the liquid pressure? Loss of liquids. Right? And followed by the how this Pascal's law is applicable in our day-to-day life. Right? So that's all for today. Just a new chapter. One day, next 2 days, we can finish up the chapter. In meantime, you need to work on that assignments, whatever is given levels. Just after first go through the concept. Once you write the concept in your notebook, you can directly solve each and every question given there without any problem. So during next, after completing syllabus, we'll go for the revision session. We'll complete all the worksheets if you are not getting. Right? So that's all for today. Thank you all of you. Have a wonderful day. Thank you.